In this video, we are going to be looking at some more practice with derivatives. So you see here in problem number 1, we have y equals 2x minus log x plus 3. So we'll take the derivative of each of those terms one at a time. Right, y prime would then, the derivative of 2x would just be 2. The derivative of log x, the derivative of any logarithm is 1 over the argument. So it's going to be 1 over x. But because this is not natural log base e, we also have to multiply the derivative of 1 over times 1 over the log, natural log of 10. Whenever you have a log that is not natural log, this is how we take the derivative. The derivative of 3 is a constant, so it would be 0. And that is our answer to problem number 1. On problem number 2, similarly, we have 3 terms, so we'll take their derivatives individually. So we'll have y prime. The derivative of x to the 5th, we use the power rule, and we'll get 5x to the 4th. The derivative of 5 to the x is very similar to the derivative of e to the x. There's just one extra part. So once again, when we take the derivative of e to the x, we simply get e to the x. But when we take the derivative of some other number to the x power, it's that number to the x power similar to above, but then we have to multiply it by the natural log of that base. So when we take the derivative of 5 to the x, it will be 5 to the x times the natural log of 5. Now, e to the 5th, e is really the number 2.72. So when we take it to the 5th power, it's just going to be a number. And like any other number, like 3 above, the derivative of any number is just 0. So with problem number 2, our derivative answer only has the 2 terms, 5x to the 4th minus 5 to the x times natural log of 5. If we look at problem 3, that is our quotient rule. So let's review our rule for quotients. So here we have, if we have a quotient function where it has a numerator and a denominator that are both functions, the way we take its derivative is we say the derivative will be the bottom function times the derivative of the top minus the top function times the derivative of the bottom, all over the bottom squared. So as we do that in problem 3, we'll call that f prime of x instead of f of 3. We'd write the bottom function, x squared minus 1, times the derivative of the top function, which we will take individually by parts. So our derivative of x squared is 2x. The derivative of minus 3x is just going to be minus 3. And the derivative of 1 is 0. So the derivative of x squared minus 3x plus 1 is just going to be 2x minus 3. And then we subtract the top function, which is that x squared minus 3x plus 1, times the derivative of our bottom function, which is going to just be 2x. Now in our denominator, we'll have x squared minus 1 squared. So we followed that formula exactly. Now we simplify that numerator because we are going to have some terms cancel. So when we take, we're going to multiply it out and add like terms. So x squared times 2x gives me 2x cubed. X squared times a minus 3 gives me a negative 3x squared. A negative 1 times 2x is a negative 2x. And a negative 1 times a negative 3 is a plus 3. Now when we take the product of these two expressions, we're going to have to change the sign because they are being subtracted. So x squared times 2x is going to give me a negative 2x cubed. X squared, 2x times a negative 3x would be a negative 6x squared, but this negative will make it a plus 6x squared. And 1 times 2x is just 2x, but we will be subtracting it. And in our denominator, of course, we have that x squared minus 1 squared. Continuing, the 2x cubes will cancel because it's a positive 2x cubed minus 2x cubed. Then we have a negative 3x squared plus 6x squared gives me a positive 3x squared. A minus 2x minus 2 more x's gives me a negative 4x. And then we only have that remaining 3 in the numerator. And our denominator will remain the x squared minus 1 squared. Now, we typically don't multiply this denominator out, so at this point, we are done. Looking at problem 4, we have the product rule, which when we take the product rule, we are going to take the first times the derivative of the second, and then the second times the derivative of the first. So the first is just that x minus 2. The derivative of the second will be 1 over x. Then plus the second natural log of x times the derivative of the first, which would just be 1. Now, there are a couple ways you could write this. I've seen people write the answer taking the product of these two. They just wrote x minus 2 over x plus the natural log of x. That is a good way to write it. When I thought, well, maybe I'll multiply these out. If you do, 1 over x times x gives me 1, and 2 times 1 over x gives me 2 over x, and then plus the natural log of x. Both of those answers are equivalent and completely fine. Let's go on to problem number 5. In problem number 5, once again, we have the quotient. So we'll have to remember our quotient rule. Go ahead, pause the video and give this a try, and then we'll look at it together. When you take the derivative of a quotient, we take the denominator times the derivative of the numerator. Now, in my numerator, I have two terms, t and the natural log of t. So taking the derivative of the numerator will involve the product rule. Just like up here, when you did the first times the derivative of the second, plus the second times the derivative of the first. So we have to do that here. So the first, t, times the derivative of the second is 1 over t. And then plus the second natural log of t times the derivative of the first would be just 1. Now, that is just the first part of my quotient rule. This is the bottom times the derivative of the top. Now we look at the top. This should be minus. Quotient rule says you subtract. Minus the top, which will be t natural log of t, times the derivative of the bottom, which is just going to be e to the t. All right, so, and down here, we'll have e to the t quantity squared. All right, let's clean up what we have inside these parentheses. So here, when I take t times 1 over t, the t's cancel, just leaving me with 1. So we'll have e to the t, and inside that first parentheses, we'll just have 1 plus the natural log of t, because natural log of t times 1 is natural log of t. And then we could write this, well, we'll put the e first. So minus e to the t times t natural log of t. And all of that is over e to the t quantity squared. Now I notice I have an e to the t in this first term, an e to the t in this second term, and I obviously have an e to the t down here. So fully simplifying this expression requires us to cancel some of those e to the t's. Having both of those e to the t's, I'm going to factor them out of that numerator. So my numerator is going to put that e to the t in front, and what's remaining is what we have inside the parentheses here. So 1 plus natural log of t minus t natural log of t. That's these two inside parentheses combined, and this is over e to the t, and e to the t squared is really like e to the t like that. So now, using my excellent algebra canceling skills, I can cancel those two, and our simplified expression becomes 1 plus the natural log of t minus t natural log of t over e to the t. All right. In the next video, we'll go through a few more. Thanks for watching.